Or deviation from horizontal, sorry. I apologize, it's late.
Right, over the total distance.
Right.
Okay, so it slopes less than an inch.
Yep.
Brilliant. So when you're saying, what's less than an inch? Is 0 less than an inch?
Yes, 0 would be less than an inch.
Okay. Okay then. So
posted the measurements.
So how much more than less than an inch, possibly 0, will Sean get when he does 400 meters? Sean doesn't want to predict how much. How much would you predict that the slope of the water level Sean will find over 400 meters?
Shouldn't be more than maybe a few inches, maybe a foot. I would have to run the numbers. I'm just spitballing here.
That was funny, though, for real.
Nice.
0. It could be 0.
It is less than an inch, 0. Definitely.
Exactly. That was classic. I'm sorry.
Right. It is definitely less than an inch. It's measured. It's been measured every 3 to 6 months. The records are public.
So
you just want to say no, and I get it.
For 400 meters, you said possibly up to a foot.
I said I would have to run the numbers, and I'm not going to do that right now because it's after 2 o'clock in the morning.
So, when you say possibly up to a foot, you've no rough idea, rough estimate.
No.
Don't take advice from fools. Everything that they say is in vain. Never take advice from fools. We all know what they do is in vain.
What are you expecting to get, and what is that expecting to measure or verify in your mind from doing this?
Whether or not there will be vertical drop, and I am giving no predictions to the result.
Okay, vertical drop because the Earth is a sphere of a radius of 4,000 miles roughly. Like that's what you're attempting to measure that drop over 400 meters.
Whether there is vertical drop or not is what I'm just testing for, and I'm saying it that way because I don't want to be said that I am presupposing the results because I'm not. I think it works better that way.
Yeah, I think we saw one of your pictures. I might be able to get it. It was
I'll have something that's much better.
If horizontal, then flat. If slope, then curve.
In a nutshell, yes.
Never take advice from fools. Everything that they say is in vain. Never take advice from fools. Everything that they do is in vain.
And what do you think you're going to find over 400 meters? Are you going to use a measuring rod, or are you just going to randomly sight it, or?
I can use a measuring rod as a reference point, but at the same time, citing it and showing this, I know how to show the site through some type of recording device, so you'll see what I see, rather than. Because if you're just using a measuring stick, it's a little different. It's not the same thing as what I'm trying to accept. It would be a reference point. It's not the same thing as what I'm trying to accept. It's not the same thing as what I'm trying to accept.
Don't take advice from fools. Everything that they say is in vain. Never take advice from fools. We all know what they do is in vain.
Then we can establish what terms are at some point. But the way I explained it is exactly how it's explained and how you would measure for it. You would use the drop angle, the slope down to the second water level, and that would be the clear measurement of curvature. Now, you may want to conflate curvature and slope to be one thing in this test, but it's not. I've explained that twice now. And to be clear, that vertical drop is measured by a slope called the sloping angle. It is a term used in measuring. It can be used for elevation and also be used to check if a level, 2 level points, have a vertical drop as well.
I have enough confidence in the things that I know. I have enough wisdom to see the logic will be shown. I got one chance to show you what I got. I got one chance to show I'm confident or not. Self-evident reason, deductions and conclusions, and the fools are running away.
How much drop are you expecting to see over 400
I have no clue.
meters?
I'm not going to even say a number. I have no clue.
It's not what you say, it's only what you can prove. You better watch your step, you better mind your P's and Q's. You got one chance, show me what you got. You got one chance, show you confident or not.
So, tomorrow, 6:30.
Yes. And I will 1000% be there.
Caught in a matrix of all of these fakers, society spinning, and I'm just here living on the ground.
All right, okay. So how much slope did they measure on that?
The deviation from curvature is less than an inch.
But I'm going to say this real clear. At no point will you not see vertical drop. But I'm going to say this real clear. At no point will you not see vertical drop.
Self-evident reason, deductions and conclusions, logically thinking, and the fools are running away. You're flipping over backwards to show me where you think you are. Your model dictates that you never see too far. Shrinking in the distance, you can do fuck all with an angle, and the fools are running away.
And I brought up the 400 meters because this is 100% off of what Bevan and their group was doing. Is I do plan on building a 400-foot water level to show exactly what I've been trying to say happens. Because in that same situation, the same thing as I was saying with the mountains, I say we'll do the same thing with the water level.
Yeah, Bev's already done it. Yeah, Bev's
No, he
done
hasn't.
it. Yeah.
No, he's done the water level, but he hasn't cited it like I was saying. Because when you cite it, the same effect that I'm saying happens with those 2,000-foot mountains will be the same effect that happens on a water level. Bev has not checked that. Bev will tell you he hasn't checked for that. He says you can't check for it. I say
Effects.
you can. That's why I said, because of this conversation, and I think I've told Bev, I do plan on building a water level and doing that test. That is a test, Geo, that I do plan on doing.
Well, I don't know why you're really messing with optics at that point. You can just measure it directly.
No, you can't, because then you're just talking elevation still. You would literally cite it to void the elevation that you're thinking you're looking at. A water level doesn't care about elevation. When it's set, it's set. It could be 60 feet in the air. If they're level, then they're level. Elevation doesn't matter what's under it. So
Ready for a challenge shot?
Check whatever, man. Whatever you want to do, Bev.
Okay,
and Bev,
Let's...
just to get things clear, because there's a lot of people in the chat that like to amp things up. I don't talk shit, and you know that. But everything I've said when you weren't here, I said to you before. Same stuff about elevation and how you won't do the test the way I asked for it because it's not your test. I've said those things to you, correct?
You've said loads of stuff. I don't know about what you said when I wasn't here.
The same thing.
I haven't got a clue.
And you can go back.
Well, before we continue, right? Is there any way, rather than us picking up with whatever you've got in your head, can we lay this out like you want to, right? There's first off, we state what we're going to achieve, however you want to do that. Then you lay out your method for achieving it properly, like fully lay it out.
Yep.
Geometric layout, and how you're going to do it in reality. And then we can put our conclusions together, right? Would you like to try and do that?
Absolutely.
Okay. Do you want to go first? Because it looks like it's on your mind. No, I'm not saying now. I'm saying let's get this together. Let's structure it. And then we can come back later or whatever with Geo.
Yeah, absolutely.
Brilliant. So the idea is how we are going to measure. What is it we're measuring? Because I heard you something about elevations. You don't want to measure for elevation. So what is it that you want to measure for?
I'm going to measure. I want to show how you would measure for curvature.
Curvature of what?
Not be
Sean?
Earth. Of Earth.
Like a mountain.
No, of Earth.
Yeah, a hill, a mound of dirt.
No. Curvature of Earth.
Yeah, well, like the Earth would be a mound of dirt. In my eyes, no. You want to measure for the curvature of that.
No.
Okay.
Again, I will say it again. Not elevation. Curvature.
Yeah, I know what curvature is. It's something that isn't straight. Now, where do you want to do this? Like,
and I will do
what you want to do it with.
As my references, like I said, I'm going to build a water level and at 400 meters.
Okay, so
same like you guys, pretty much the same setup you guys had, I guess.
Okay, so you want to test for the curvature of the water level.
No, curvature of Earth. Using a water level.
All you'll get is a water level, and then you'll be able to use the water level to measure elevation changes of the land.
No, you can check elevations using it, but for the test I'm talking about, where I would use a water level to establish level, right? So we know that both ends are at the same elevation of each other, right? Level, right?
Right, okay. We are using the water level.
Okay, right? You're using the water. Okay, I'm telling you what I'm using the water level for. I'm using the water level to not have to negotiate between topography. It's because I know from one end to the other is going to be level. There will be no change between the two, right?
It's a straight line, right? From one end to the other.
No, it's a level line. And it's not a straight line, which is what I'm going to establish is curvature.
Okay, I'll say it again, Sean. So what you're saying is you, Sean G, want to measure the curvature of the water level, i.e. the water level to you is not a straight line.
The water level is level and does not produce a horizontal between the two of them.
It's not straight.
Does not produce a horizontal between the two of them.
Okay. But are you saying it is not straight from one end of a water level to the other?
I'm saying one will deviate from your horizontal from one end to the other. What I'm saying is exactly what I mean to say. What you're saying is not what I'm saying. I want you to hear it again.
What I'm saying is, what is it that you are trying to achieve? That's all, Sean. Like, it's just a very simple thing.
I want to achieve and show that between 2 points of a water level, it is not on the same horizontal plane.
Okay. So you are saying that a water level does not produce a horizontal.
Between the 2 points, no. It creates a level.
Okay.
It is level between the 2 points.
Now, if it's not horizontal, are you saying there is a slope?
Yes. I am saying there is a slope that you will measure due to curvature.
Okay. Now, that slope, you say, is measurable.
Yes.
Brilliant. Now we're getting somewhere. So, can we set out a method, like a premise, then the method, and then, well, I don't know whether we can do the conclusion yet, or you anyway, because you've not actually performed the test. But
Yes.
do you
I still
want
have
to
to
go
double check.
along with how you would set it out and how you would do it and lay it all out in a presentation for us?
Right now, or you're talking about later?
Like, can you do it in later on today or something? I mean, you sound like you've...
Absolutely.
Oh, brilliant. Well, that's good. Yeah. And then I can lay out our method, right?
Mhm.
Okay.
Okay.
That sounds fantastic. And what can we call it?
You mean, what do you want to?
What do you want
can
to call
name
this?
it
What
you
we're
can
doing?
Call it whatever you want to call. I'm not really interested in creating a title for the test. Just doing it. That's it.
So would you call it a curve or a slope?
Wait, what? What are you talking about? The conclusion? Conclusion would be measurement of curvature.
Okay, there you go. That's it. Okay, so what you aren't doing, because you can't really set out a test to measure a slope, and then at the end of it say you've concluded that you've measured curvature. That seems a little bit strange.
No, because the
a
sighting
slope
between
does
the 2
not
points,
equate curvature, though.
Yes, it does. It's the vertical drop. I'm sorry.
A vertical drop is an elevation change.
No, nope. See, you're wrong.
Okay, I'm just checking.
Again,
I just want to make sure that everybody will make it easy.
There are, so you can say there's slopes, which is like a mountainside or a small slope on the side of a road. Yes, those are slopes, but the vertical drop, when you're talking about the surveying measurement of vertical drop, it is a slope.
Okay. Not curvature.
Jesus Christ. You measure curvature and you use the vertical drop that you're getting from one point to another, which is called a slope, to establish curvature.
How? Okay, wait a minute. I don't want to, you'll put that into your test, right? Into your presentation.
Yes, I'll explain it very clearly, like I have
Keynotes,
many times before.
Then, right? We need, at the beginning, a statement to say what you're going to be doing.
Go ahead. No, I will explain the test just as I explained it. And if you don't understand the terms, then we can establish what terms are at some point. But the way I explained it is exactly how it's explained and how you would measure for it. You would use the drop angle, the slope, down to the second water level, and that would be the clear measurement of curvature. Now, you may want to conflate curvature and slope to be one thing in this test, but it's not. I've explained that twice now.
Okay, well, I'm just, for everyone's benefit, Sean, this is, in order to say what's going to happen, right? First off, we say what we aim to achieve at the beginning, right? Then we explain a method and try and make it as geometrical so everybody can understand what we're doing.
For the case of the argument, I don't need to tell you. I don't need to have an end result to establish when we have the beginning of the conversation, because literally this measurement does it for itself.
Yeah, I hear you, Sean. I hear what you're saying. It makes sense.
Well, just
I'm making it very clear what I'm saying.
It
You're
makes
the one
clear to
twisting
me,
what I'm
bro.
saying and
okay.
Very
conflating
clear to
words.
me.
I'm
Not
just
Yeah,
necessary.
after.
I understand. And
A
I'll try to come up
method.
with I keep trying to guess at the variable that could be making that horizon do the phenomenon it does, making it look like, you know what I mean? But I appreciate your evidence. You present it pretty clearly, bro. Appreciate you.
His evidence. Has he presented any evidence? I might have missed that.
Well, from time to time he does, doesn't he?
Save it for this presentation, though, Sean. Right?
Sure.
Okay. When can we say this is going to be occurring?
What time is it right now? The best way I can do it is 10 hours from now, because I know we're on different times. It's 2 a.m. for me. My noon is my free time. So 10 hours from now
Sweet.
would be the best.
That's good. 6 o'clock ish or 6:30 for us.
Yeah, I mean, Sean,
That
exactly. Like if you come up, I mean, that's the thing. Like in this community, like I mean, there, we can do research projects and share the results as well. So I mean, some of these things that you're claiming, like if can you actually verify them in physical reality? That's the real deal right there. To be able,
everything I'm saying, I plan and can be done in reality, physical reality.
That's
it's not
just what we
a
want.
think thing.
I've been asking for that for ages, Sean. This is going to be great.
Every time we've had this conversation, Bev, I've explained to you that I'm in the process of creating this same test, but doing the beyond test that I keep asking for you to do.
Yeah, well, see, that's the problem, Sean.
But no, you're right. 100%. You are 100% right.
You don't even know what I'm right about. But I mean, I guess I'm right.
Asking you to do the test I want is unnecessary. I need to do the test so that it can be done myself. I get that.
Yeah, that's
because
I'm already thinking about our test, and then you're telling me how we can modify the test that we've already done to accommodate you. But I mean,
get results.
Pardon?
Modify a test to get further results. What you've done is elevation. You're not even, your test doesn't even distinguish between curvature and no curvature. It's
straight line test, John.
Mm-hmm.
So yes, it like the idea was to keep it as simple as possible. Yeah. I can go over our test, right? Don't worry about our test.
I don't need. You've already gone over. I get.
Well, I know I can explain it, right? I'll do the same as what you're going to do. I will present an other test.
Okay, and I whether it's a preview to what I'm going to ask you, no matter what I'm going to ask you, how you verified that straight line. No matter what.
Well, it's not like Sean. We've gone past the point of our confusion of what each other are trying to do, and what we're going to do now. We're just going to present it, and then everyone else can have a go at looking at it, judging the validity of what we're doing.
But you will have a way to explain how you verified the straight line between the 2 points, right?
Absolutely, yes.
Perfect.
I will, yes. I hope you will too. Looking forward to this. Knew there was something that got me up early.
It's like a Mexican standoff. Get your pistols in your holsters.
Well, I mean, that's good. We were asking for since the debate yesterday, and then something else. I mean, that's good. Do you want to do a backstory as well?
Nope.
Just straight into it.
Straight into it.
Yeah, I don't think we need to play games and dance around terms and all that crap. Let's go straight to it.
Sweet. Did I hear you? Are you going to be bringing mountains into it?
I will use whatever I need to explain my point.
Nice. I understand you don't want to give it away.
I've explained it at least 7 times, so I really, there's nothing to give away. I just don't want to repeat myself again.
We are actual measurements of curvature or slope, not effects. I never understood what an effect of curvature is. Just come to mind. A slope isn't an effect of curvature, is it?
It's a measurement. A slope is a measurement.
Uh-huh. Actually, I think the drop would be a measurement. Just a minute. The missus is shouting.
Same thing. Vertical drop, slope, same thing.
Got to make sure you keep your altitude measuring tool calibrated to the correct
Elevation
premise.
plays no point.
Of course, elevation plays a point in slopes. It's about elevation change.
No. You're right. There are slopes that when you're talking elevation, but in the slope that I'm talking about, I am talking about the measurement of vertical drop, which is a slope, and it's not topography.
I wouldn't call it a slope. It's like a conflating term. I would just say
No,
curvature.
the term is a measurement of vertical drop. If you're talking about on a mountainside, it's the measurement of vertical drop. In elevation, there's a difference. It's still a slope, though. These are terms that are used for all these aspects. If you want to only single slopes to only elevation, you're doing it wrong. It is not only when you're talking about elevation, when you're talking about a mountainside. It can also be talked about a vertical drop between points. And if those 2 points are level, then there should not be a vertical drop between them if it's not curvature. Very simple.
Fair enough.
So, Bev, you can keep conflating slope to only elevation, but I've made it very
You mean
clear.
when those 2 points are level to each other, right?
Yes. If those 2 points are level to each other, there should be no vertical drop.
Fair enough.
And to be clear, that vertical drop is measured by a slope. It's called the sloping angle. It is a term used in measuring. It can be used for elevation and also be used to check if two level points have a vertical drop as well.
How is it measured?
Say again?
How is it measured?
Like with the tool, you mean? Or
yeah, you're saying it's the measurement is called a sloping elevation or what have you. How is it measured?
It's vertical. You can use auto levels, theodolites, total stations, GPS. I mean, there are multiple methods.
How about just a water level?
Just a physical measurement. Right?
That's actually percentage. I think you may have just came in. That's actually exactly what I want to establish using. I want to use a 400-foot or 400-meter water level. And if we know those 2 known points are level, there should be no vertical drop when you use an optical tool, auto level, theodolite, total station, to sight between those 2 points. From one point to the next, there will be no vertical drop.
Why wouldn't there be?
What? Say again? Why wouldn't there be vertical drop?
Yeah, why wouldn't there be? We know that optical measurements aren't the same as physical, tangible measurements. So why wouldn't you expect any deviation because of refraction?
Well, at 400 meters, you're not going to have that much of an issue with refraction.
You could
1,200
have a little
feet is
bit.
not enough to. Or better yet, the amount of vertical drop is not going to correlate with amount of refraction. So yeah,
Okay,
there may
let
be
me say it this
refraction
way.
between.
So if we physically measure them to be level with each other, right?
Yes,
And
which
then
is already which is easy.
optically they're not.
Right?
Wouldn't
Mhm.
that be an issue with our optics since we've already physically confirmed that they
Nope.
are level?
No, that's the issue that would be had, because if it's a flat Earth, or better yet, no curvature, there will be no vertical drop.
Yeah, so I don't know how you've like determined that maybe the optics aren't just reliable. You're automatically assuming that
Well,
that
we use these.
the nature that the physical
I see
nature
what
of
you're saying.
the Earth is different, let alone then just like the optics being off.
You're talking about the topography, right?
No, I'm talking about if we physically see that they're level with the water level, and then our
Yes.
optics aren't showing that, maybe there's a perspectival type of effect that's preventing our optics from matching our reality.
I wouldn't. Well, then we got a real issue with everything we build, because a lot of these tools are used to do exactly that.
Yeah, so that's why like we've been talking, these past year or so, especially me and Jeremy, about how we need a tangible, straight thing to measure against the water level instead of using optics. Because if we rely on optics, then we open ourselves up to those issues, the refraction and perspectival issues.
Okay. Well, again, at 400 meters, especially on numerous tests throughout the day, would show almost the same results basically. And if refraction did play a factor into it, you would see that in the multiple measurements that you're taking. So if I do 10 tests throughout one day, I'm going to see any refractive effects that or any high refraction effects that are happening. I'm going to see it, and I'm going to see when it happens throughout that day. But I'm going to say this real clear: at no point will you not see vertical drop.
I mean, I don't know about that.
Well, that's what the test is about, right? Like I said, I am 1,000% in the works of building a 400 meter water level and showing exactly what I'm saying to make it very clear and show that 400 meters, these atmospheric conditions aren't going to affect it like that.
How much drop are you expecting to see over 400
I have no
meters?
clue. I'm not going to even say a number. I have no clue.
Oh, okay. If
Did
you
you say
got a
400
number,
meters or 400 feet?
400 meters.
would you use that
1,200
number
feet.
to be able to, you think, to make some sort of a calculation of the
What do you mean?
size that you put to it, right?
What do you say it again?
Well, over 400 meters,
Mhm.
you're going to measure a slope.
I predict I will.
Okay, now with that measurement of the slope, will you be able to make a calculation to measure R? Well, calculate R, right? Do you think you could?
I think I could. Am I going for that? No. That our value makes zero difference.
So all you're after is measuring the slope of the water level.
The vertical drop. We're going to call it vertical drop.
Yep. That sounds good to me. Over 400 meters of the water level.
Yes, sir. Right. Yep.
Nice. You know you're up against a long thought out test that's already been implemented.
I don't think you've done it the same way I'm talking about doing it, so I'll say we'll see.
Nice. Is there any sort of particular time you would like us to do a presentation of our test?
When I told you, you let me know when, and I'll be there for it.
But you say, like, you've already said that you're going to do yours later today.
Yeah.
Okay.
No. Okay. I will present what I'm going to do. I cannot present to you something I have not built yet. I have said at least 7
Just the
times.
method is what we're talking
Okay.
about.
Yes.
You,
Yes.
you're going to present
Absolutely.
your method
Yes.
later today.
From start to finish. Yes.
Okay. Saying, do you want us, i.e., me, to present our method like straight after? Do you want to do
I
like
don't
a
care.
double whammy?
Either way.
What do you reckon, Gio?
I think that'd be a great idea. So people have a good idea what your test is representing, and they can see what my test is representing.
Okay, so we put both of them together, 6 o'clock today.
Yes, 10 hours.
Sorry, 6 o'clock PM or UK or 6:30.
Yeah.
Okay.
I think,
How long do you reckon yours will take?
I don't know, about 20 minutes at best.
Wow, that'll be good. I think our test. I suppose I might be able to do it in that sort of time. Guess the questions afterwards will come, right? Do you do your test and then obviously some questions from people, and then I'll do my test and then questions
Sounds
from
good.
people. Nice. I love it when we structure stuff like this. Well, I will put a thing out on the community then for later that we're going to be doing this.
Sounds good.
Can we say measuring the vertical drop slope of the water level?
Call it whatever you'd like.
But that's okay with you. What like this is your test. What are you calling it?
I'm not calling it anything. It's just my test.
Sean's test.
Yep. I feel like if I give you a title for it, it'll just be an excuse for some type of presupposition to my results or something. It's not necessary. So doesn't need a title.
Well, it does really, because I'm trying to put it out as a community post on YouTube. I would like to be
you're
able
a YouTuber, you present these live streams, I'm sure you will come up with some kind of clever title for it. I believe in you.
Okay, well, I think I'm going to be attempting to measure the vertical drop slope of the water level with Sean G.
Whatever you would like to call it.
That's what I'm just doing it now. Oh, get it. Do it on the PC. Easier.
Excuse me.
What is that in America time?
It'll be noon Central Time. No,
Is that UTC?
what time zone am I in? Central. No. CT, Mountain, Pacific Mountain, Central. Yeah, Central Time, U.S. It's my noon. West Coast, 10 o'clock. East Coast, 1 o'clock. For the Americans here. I don't know what the UT time is.
6 o'clock or 6:30 my time.
So say 6:30 your time, just to make sure that I'm back in time. I literally work 100 yards from where I live, so it won't take me time to get back. Fuck. Bev, this is purely my fault. Can we do it for the next day?
Oh. So not
'Cause
today, tomorrow.
Yeah, because I will not be here at that time, and I just remembered it.
Okay, that's good. So tomorrow, 6:30.
Yes, and I will 1,000% be there. I just literally forgot and just remembered that I'm going to be on a road trip for the day for work, so it would actually be a very bad time, and that is my fault. I do apologize.
That's fine.
Good chat, guys.
Sounds like history in the making. Maybe after tomorrow we can put this experiment next to the Bedford level, mark it down in history.
Well, I got a logical argument for Bev. You say he was leaving? Damn, I had a serious one for him.
I mean, I'm just I can't write and talk at the same time. My brain just won't function like that. Sorry. If I'm typing.
I got you, bro.
So
I was just thinking like this, man. I mean, trying to keep it simple and kind of on topic to the arena. You know, I was thinking logically, if we're trying to map all the areas around and places that we travel, you know, the best map is going to win. The best map is going to be the current one. Our
most
best
accurate.
guess will render itself as the full projection. If there can be made a better map, there will be made a better map. We will always strive to improve our maps. All these, I think, are logical things that we're all going to get behind. You know what I'm saying? Anytime anybody disagrees with one of them, y'all let me know.
Do you not think that we already have accurate maps?
You ain't saying shit. You didn't say nothing. You just said it real quietly, didn't disagree, didn't say nothing.
On Bev's behalf, he did say he was doing something.
You're right. You're right.
And, like, isn't it sort of customary to let somebody finish what they're saying as well?
Yes, you're the nicest,
without
sir.
interrupting.
You are a gentleman.
So, my rebuttal to that would be, do you not think they've already got super accurate maps?
Yeah, I guess they know I guess they know all the. They know all about the globe, then, don't they?
Well, they seem to know all about the land enable to map it. Yeah, to scale.
It'd be a flat open map.
At least the land masses.
Just wondering which way is east and west when you're standing at the North Pole.
Yes.
Is there even an east
If
and
you're
west?
standing on the pole, I don't think so. I don't think so. I'm going to say no. There is no east or west at the North Pole. It would only be a south. But if you take a foot off of that, then there would be.
That's a cool point.
The better question would be, how is there not a South Pole, a magnetic South Pole, if we have a northern one? That's a bigger question.
Yeah, and how is it that there are apparently different compasses that you need to use from the North Pole to the South Pole?
I'm pretty sure the line's just drawn different. The red little arrow is just colored different on the other one. Pretty sure that's the only real difference. And I think a 3D compass would be a better choice, because then you wouldn't have to distinguish between the two hemispheres.
You mean like a rolling compass on the top of your dashboard on your car, like one of those bobble ones?
No. It's it looks like it's inside like a. I don't know how to explain. I can show you. I have a picture of it in my. It's pretty badass, actually.
It's like a sphere shape.
Kind of, yeah. Here, I'll show you. Here, I'll put it in the chat right now.
All right, so you're gonna
That's
you're
one
gonna
little
film
thing
it.
I'm trying to figure out.
You're gonna record it, and then you're gonna present it, and you're gonna show the recording at the presentation of it.
Yeah, pretty much.
And what?
That's the
And
only way I'm going to be able to do it right now.
okay, I guess like could you just summarize what it's gonna be? Because like I was listening, but I just do you have like kind of a summary of what you're gonna be doing and what you're gonna be measuring?
Yeah. It's going to be a 400-meter water level, and I'm going to sight it to verify whether or not the level is a straight line, a horizontal from one point to the other.
Oh, okay. And then are you gonna what are you gonna sight it with?
I'm either going to use an auto level or a total station, depending on what I get my hands on first.
Like, have you already
Either
got a
one,
400-meter water
perfectly
level?
fine to me. No. I told you.
I didn't think you were going to actually do it tomorrow. I thought you were just going to present your.
Oh no. Yeah. I'm just going to present my schematics of it, basically.
Yeah.
Or then, yeah.
Yeah, Gio, he's not actually going to do it.
Yeah. Yeah. Sorry.
That would be asking too much.
Yeah.
Yeah.
Okay.
Not right now. Well, how's it asking too much if I've already established that I have to build it still? If you want to wait and build it, we do that too, and that way I'll do it. But otherwise,
no. I just want to see your method, right? Because
yeah,
the connection's going. I think. Yeah. Just so tomorrow you're not going to be recording anything and presenting it tomorrow, are you?
No.
Well, that's what it sounded like. Gio was asking you, and you said yes. It sounded like.
Oh no. Okay. I thought he was talking about the same thing we were. My bad. No.
And what do you think you're going to find over 400 meters? Are you going to use a measuring rod, or are you just going to just randomly sight it, or?
I can use a measuring rod as a reference point, but at the same time, sighting it and showing this, I know how to show the site through some type of recording device, so you'll see what I see, rather than because if you're just using a measuring stick, it's a little different. It's not the same thing as what I'm trying to accept. It would be a reference point.
You know what would be cool? There's so many potential.
Like what Ben wants to do is actually is perfect. Go ahead.
I think you're roboting a little bit, but I think I kind of heard, yeah, but it was cutting out a little bit. No, I was just going to say that within a community, it'd be cool to, like, there's ways that, like, for example, if you put together what you're putting together, and then you present it, people could, give feedback and sort of. You could even get into like a rating thing, like, rate it like 1 to 10, or even like rate it for, quality of just like of what it's actually doing and whether, like the validity of it basically. And Absolutely. What it actually shows, if anything, or if there's issues with it. And so like within a community like this, we could actually have like that kind of process. And then there could be that people could be, it doesn't have to be like a competition like in an aggressive way, but it could be could have some of that energy, like actually what you can put together, what you can present, and the validity of it.
RateMyExperiment.com.
Yeah, you could do like a costing analysis as well, right? How much do you reckon it'd cost to do that test? That could be in, right?
Actually, fairly cheap. I think the most expensive thing would be our level. To build that kind of aspect of it, just the auto stuff. Otherwise, simple.
Yeah, I think
that's basically the premise of what I want to do.
Sounds a bit better.
Do I got a bad signal? So
yeah.
Yeah, my bad, guys. My
Yo, I love you all. Hope you're all happy and healthy.
Thanks, percent. You too.
Thank you.
Yeah, I think you're trying to say something, Sean, but
And even to the robot.
it's not making it through.
Yeah, I don't know if robots can be happy, but they can definitely be healthy.
Well, I guess Sean's maybe still listening, but what is his like? Did he say what his expected result is going to be? Because I mean, he's claiming to measure the curve of the Earth over 400 meters.
No.
Yeah, his expected result is curvature, but he didn't say how much.
Slope. He's going after the slope.
And instead of curvature, he prefers the term drop from vertical.
Yeah, slope is a more accurate term, I think, for Sean. That's what I've put anyway. Sean G's presentation of his method to attempt to measure the vertical drop of the water level slope over a distance of 400 meters.
Right. So what is his expected slope then?
He doesn't want to predict anything, I think he said.
He'd have to really verify that he's at sea level or that he's at, because it just seems like a lot of ways, if you don't set that up correctly, you could just fudge the sighting of it. But
elevation plays no part. As long as the water level is set up correctly, that's all that's needed to be correct. Elevations doesn't matter.
so what is your expected, what are you expecting to get, and what is that expecting to measure or verify in your mind from doing this?
Whether or not there will be vertical drop, and I am giving no predictions to the results.
Okay, vertical drop
there's
because
vertical
the Earth is a sphere of a radius of 4,000 miles roughly. Like that's what you're attempting to measure, that drop over 400 meters.
Whether there is vertical drop or not is what I'm just testing for. And I'm saying it that way because I don't want to be said that I am presupposing the results, because I'm not. I think it works better that way.
What's your hypothesis, though?
That if there's curvature, there will be vertical drop. If it's a flat Earth, a plain Earth, it will be no vertical drop. That's my hypothesis.
Yeah, I think we saw one of your pictures. I might be able to get it in a minute when I've done this.
I'll have something that's much better to present.
If horizontal, then flat. If slope, then curve.
In a nutshell, yes.
Yeah.
Wouldn't it be the other way around? If horizontal, then flat?
No.
If curve, then slope?
Yeah, that's what he just said.
No, he said if slope, then curve.
Right here. Well, vertical drop and slope,
Yeah,
same
if
thing.
the slope of the water level, then it's curve.
Yes, it'll be curve.
We've got the picture.
Yeah,
and
you said it.
everything.
That said it right. And I will be showing no drawn pictures. I'll create something more presentable that's not off the cuff within 3 seconds of a conversation.
You're basically saying that horizons should fall below eye level, right?
Absolutely.
I have a question. Maybe I could answer this myself just like by searching one of those time-lapse videos. But when you have a time-lapse of the horizon, like at the shore or something like that, and the distance to the horizon keeps on changing with the different atmospheric effects, does the line where the horizon is change at all?
No, I think I would say off the top of my head, it'd be just a foreground that you're referencing of the horizon. If you did see something, so basically, or I guess the best way to say it is no, I wouldn't. It would only change due to your perspective of it. If you change locations or elevation, I guess distances, all these things, it's always going to be apparent. It's not a fixed location.
Do you like that? Would that be better? Because there's your picture, Sean.
Yeah, the picture
if,
that I drew,
if flat,
that I
then
drew
horizontal.
in the middle of our conversation, that I will not have for tomorrow. Tomorrow I'll have something very much more presentable, and more that will make complete sense, rather than something I drew within 3 seconds in the middle of a conversation.
But in the in the theme of the logic, what we've got there in graphic representation, right, is if flat, then horizontal. If curvature, then slope.
If horizontal from one point to the other, yes. If it's flat, I've now said like 6 times. I'm gonna go to bed now because I'm tired. And
okay.
Repeating myself is only getting irritating.
An auto level, it's like, what's the difference between an auto level and total station?
A total station's like a base unit that you. It's all it. An auto level is like a total station is like an auto level / theodolite that is a base station hooked up to the GPS. So it's just like an electronic base that you put down there. It costs like 10-12 grand. Nice bit of kit, like. But it's all just computerized, everything. You know, that thing does most of the work for you. You just press the button and it goes blip blip. And records it all.
So the auto level itself, it finds its level and its location, and then from that, it makes like a horizontal line from plumb, or what?
Yeah, you just. Do you want me to? I mean, Sean should be doing this, but I've got a picture of an auto level with the gubbins inside it that you can have a look at. And
I just thought that auto levels were used to, give a level.
Yeah, horizontal.
So it doesn't give level; it gives horizontal, according to them.
Level is horizontal, right?
I know, according to us, not to them, right?
Yeah, no, but an auto level definitely establishes a horizontal, right? That
and not
level establishes a horizontal. I mean, look at it. Everything says horizontal. I mean, a level is a tool for establishing a horizontal plane of reference. I mean, but that's what the tool is. I mean, it would be ridiculous to say, right, well, we've had a water level for thousands of years. And now, because we're modern man, we're going to make a tool that we can walk around with, right, that isn't like us having to dig trenches and lay out water, whatever, to establish it. We'll make a tool that's called a level. But we won't make it the same.
So why do they call it a level if there's nothing leveling?
Yeah, it is level, though, right? That's the point, right?
Not according to them, right?
According to, I mean, who is this them?
Them, as in the Globers that have named this, and it's a misnomer for them.
A few random people on Discord and YouTube that you've got talking to, right? The model afflicted people.
No, I would say the majority. Yeah, and hold up. These are like the zealots, right? Mm-hmm. But the majority of people on this world, they're kind of been fooled by the propaganda and the deception. They're normies. They believe that if they actually were like when it's push come to shove, they'll believe that level is curved, not horizontal. So
Well-
in this case, auto level is a misnomer.
Yeah, no, I think you've been affected by these arenas that you've been in, right? Because if you go out and talk to people, the average people, level's horizontal. Obviously so, logically so, right? They
Yeah, I know.
don't
That's why I said when
believe
push
there's
comes to
any
shove.
curvature.
Because when you get them to test their paradigm, they fall back. You know, they're too scared because they have the cognitive dissonance. They're too scared to like realize that they have it wrong, so they'll dig in their heels. The majority of them.
Well, if you mention a model, there will be a cog-dis reaction. If you don't mention the model, then level's horizontal and you can just go about your day. There's no problem.
And then you have somebody like me who comes along who shows you measurements of water curving and
Measurements.
just totally throws your ass
Measurement
out
of
the window.
water curving. Ooh, I've
Did
gone
you just
through
claim
that
that?
with
You
Neptune.
said
Could
you've
you show me
shown us
something
something.
for it?
Sorry, 3 people talked at the one time.
Mm-hmm.
What?
After you made a claim, we asked you to verify that claim.
Oh, sure.
Well, before that, can I just ask you, Kool-Aid?
Yeah, what's up?
Do you think the auto level is a misnomer?
Yeah, I was listening to you talk about that. To some point, I
It
think
doesn't find a level; it just finds a horizontal, right? So
right.
technically, it would be a misnomer according to the heliocentric model.
I believe technically you are right, but it's one of those like where I'm going to actually agree with Bev here. Who cares? As long as we all know what we're talking about, that's the important part.
Okay.
And
now,
sorry, Bev, I
Okay,
didn't
so you-
mean to steel man you or straw man you if you were saying something different there.
the measurements. Do you, like you said, you've shown them to us.
Oh, sure. Sorry.
Well, percentage, I know what you
Yeah,
mean,
yeah.
because on a globe Earth or whatever, in that spherical model, level is like the distance from the center, and it's not a plane; it's a curving thing. So I know what you mean. An auto level, that's creating a horizontal plane of reference. Like, I know what you mean. It is kind of a misnomer in the globe conception of level.
Yeah, it's contradictory.
But I guess they would say that it's creating the local level to the tangent of the center of the Earth in that local spot of the Earth, and then it's actually curving. I guess that's what they're going to say.
Yeah, but even if you dissect
Local
that,
level, that's another.
if you dissect that without this tool, this auto level, only like the very central part or what have you would be the tangent, right? Like it might be level with each other, but again, it doesn't check level; it just checks horizontal. So off what tangent point are they creating the horizontal? Because the beginning and the end of that auto level, of that scope, is going to have 2 different reciprocal zenith angles. They're going to have 2 different horizontals, according to them.
Right, and be shooting up off into, off the sphere, into space or whatever. Like if it was a sphere.
So it would have to get the horizontal from like the center of the scope, and at that center area, that would be the level, and it would just be the only kind of point that they're looking at in terms of creating a horizontal. That'd be the tangent.
We got any
Oh,
of those
sorry, go ahead,
numbers,
Kool-Aid.
Kool-Aid? What?
I think
Yeah,
Kool-Aid is
I-
just going to link that same thing, isn't he?
Yeah, I was actually going to just link those exact numbers. I can't find them.
Which exact
They might be
numbers
on here. It's the David Taylor Memorial Model Basin.
of what's that?
It is an unrestrained body of water that has been sunken down to bedrock to shield it from any outside effects, including atmospheric conditions. That was created by the U.S. government World War II-ish, and has been in continuous operation ever since. 2 weeks ago, they did the latest round of measurements and showed that once again, the surface of unrestrained water deviates from level, or deviates from horizontal.
How
is the
long's
way I
that?
mentioned it.
How long is that?
400 and some odd feet.
feet.
It's not very long. Yeah.
All right. Okay. So how much slope did they measure on that?
The deviation from curvature is less than an inch.
The deviation from curvature.
Or deviation from horizontal. Sorry. I apologize. It's late.
Right. Over the total distance.
Right.
Okay. So it slopes less than an inch.
Yep.
Brilliant. So when you're saying, well, I mean, what's less than an inch? Is 0 less than an inch?
Yes. 0 would be less than an inch.
Okay. Well, okay then. So
I was long.
Close to the measurements.
So
Didn't I post in
how much
here?
more than less than an inch, possibly 0, will Sean get when he does 400 meters? Sean doesn't want to predict how much. How much would you predict that the slope of the water level Sean will find over 400 meters?
Shouldn't be more than maybe a few inches, maybe a foot. I would have to run the numbers. I'm just spitballing here.
That was funny, though, for real.
Nice.
0. It could be 0.
It is less
but it's
than an
not
inch,
0.
definitely.
Exactly. It was classic. I'm sorry.
Right. It is definitely less than an inch, and it's measured. It's been measured every 3 to 6 months. The records are public.
Okay, so
you just
when
want
you
to say
just
no,
said then,
and I get it.
For 400 meters, you said possibly up to a foot.
I said I would have to run the numbers, and I'm not going to do that right now because it's after 2:00 in the morning.
Okay, yeah. So, when you say possibly up to a foot, you've no like rough idea or rough estimate.
No,
obviously.
That's without running any of the numbers.
Yeah. So you've never run the numbers before?
No, I've not. Why would I?
Well, I don't know. It would be handy.
Okay.
Because since you've just cited something, you said you've provided the numbers for us.
Sorry, you were talking. I thought you were still talking about Sean's numbers.
Yeah, I was saying, you showing us the
Sean's
numbers doesn't give you any sort of an indication of what Sean might be finding at 400 meters.
Yeah, it'll probably be, 2.2 times bigger than the 0.4 inches that are measured here, so.
0.4 inches?
Yeah, I believe it's 0.4. I'm trying to find the exact numbers. I swear I posted them in this chat, but I cannot find them anymore.
Is 0.4 of an inch a usual thing? I mean, I'm from the UK.
I'm rounding the numbers, but yes, it's actually measured in millimeters. But when you translate it to imperial, it's around 0.4 of an inch.
Yeah, but you don't decimalize an imperial, do you? Or do
you do.
Oh, right, okay.
Oh, yeah. That's real normal.
Fine.
I mean, what's half an inch? 0.5, right?
Well, I'd say it's a half inch.
Same way to say it. Right, math. Right.
So you say...
I give up. I can't find these damn numbers. It's fine. I've posted them before. I believe I've even showed them directly to you, which is why Gio knew exactly what I was going to talk about before I started talking.
Oh, well, see, I didn't. You said you've given us the numbers, and I've never really...
Will you actually look at them? If I jump through the hoops, will you even bother to look at them?
If there's a slope, yes, definitely. Slope numbers, yeah.
So it's the David Taylor Memorial Model Basin in Bethesda, Maryland, is the name of the facility. Their records are all public record. There you go. About 50 years worth.
Okay.
Okay, so Kool-Aid.
What's up, sir?
You said something regarding atmosphere, right?
Did I?
Yeah, I think.
Well, let's go with.
You
let's go with
you went
yes.
down to get rid
Regarding
of
the
it.
device that
Yeah.
you mentioned.
Oh, yes, yes. I said it.
What did you say? Could you repeat it? Thank you.
Yeah, it is sunk into bedrock to attempt to shield it from all possible effects, including atmospheric conditions like storm.
Or you mean like weather effects? Okay, because in this arena, when people talk about atmospheric effects, they usually refer to looming, refraction, and any optical deviation.
Good call out. I do apologize. The measurements we're taking
No.
here.
I'm just clarifying.
The measurements we're taking here are from a crane that rides above the water to the surface of the water. They're never more than 8 inches. For refractive effects and whatnot, we're talking very, very minimal because we're using small distances and not looking the entire length.
I tell you what, I cannot remember right now who told us, but it was in here, I think, in Earth Awakenings. And one guy told us that I think it was Travis, by the way, who told us that he talked to a guy who is, maybe he said a mathematician, I'm not sure, but he is specializing in refraction, like literally in atmospheric refraction. And that guy, for example, said that nothing changes the atmospheric refraction besides temperature. For example, when you look it up, you will find that the pressure is gonna affect it, the refractive index. What else is usually in the equations? Like you have pressure, temperature, humidity, and things like that. Now that guy said that only the temperature that is actually, making a real difference when we are talking about refraction. Now, field altogether is a mess.
And I
Nobody
think
in the scientific field actually understands how refraction is working, let's say in the atmosphere over a large distance.
well, I know I certainly don't. There are people who know a lot more about it than I do, and I'm going to leave that to them. I like to go with things that I can more verify, which is why I talk about sailboats. Super easy. We can verify
So
everything.
my basic contention is that in itself, by the way, that the whole field, even in the scientific field, it's not established whatsoever. So when we are talking about observations, which are not measurements, certainly, by the way, the first thing that you should know, or anybody should know who is listening, that refraction kind of thing is happening all the time. We know it's happening, but we cannot quantify it whatsoever.
Once again,
precisely,
you're still trying to talk about horizon measurements, and that's not what I used. I don't bring those up. I think they're poor evidence for either side.
I'm talking about longer distances of observations, by the way.
Yep.
And 400 feet, I would count, by the way, myself. I would count it as a longer.
What about 8 inches?
8 inches, that's obviously a way shorter one.
Okay, because that's the distance of the measurement, not 400.
8 inches?
8 inches.
I don't get why did you say 400 feet before, but
that's how long the entire basin or the pool, the model basin is, but the measurement is taken from the gantry crane to the unrestrained surface of the water, a distance of no more than 8 inches.
And the deviation within that 8-inch measurement,
less than a
that was
millimeter.
1 inch, or
Less than a millimeter is the tolerances they allow. It actually holds the
Tolerance.
records
That means
for
that,
being.
yeah.
It holds the records for being the straightest and most level railroad track ever laid. Level in this case, meaning, and level and straight meaning conforming to the curvature of the Earth.
I think you talked about this before. Is this underground ship, I don't mother shipping
Yep.
facility?
Yep.
Yeah, I
They're
remember that.
testing
Yeah.
toy boats. That's it.
Yeah. Well,
Yeah, that's a direct measurement of the curvature. We know the size, we know distance between ports. We've been measuring it for thousands of years. Our measurements have gotten more and more accurate over the time until where they're published today. And my contention is they're within a meter accuracy.
now you brought in another unit, like
Oh, sorry.
altogether a meter.
Okay.
So again, the
Whatever.
basic claim is that over 8 inches, you get like a 1 millimeter deviation from a horizontal plane, right?
No, that is the deviation that the crane is allowed. In order for their deviation to be that small, the rail it's rolling on has to match the curvature of the Earth.
Anyway,
So the deviation from the horizontal plane was the first one that you mentioned, like an inch over 400 feet.
Yeah, less than an inch.
Less than an inch. Okay.
Shanji is gone now, which is
I'm
unfortunate.
back to what I said. The atmospheric, effects, like literally just air affecting what you're seeing.
Right, but once again,
over longer
8
distance.
inches.
That's what I said.
8 inches is the distance, and it's measured multiple times over this 400 feet.
Okay.
8 inches is the distance.
400 feet? What are you talking about?
The David Taylor Memorial Model Basin in Bethesda,
Okay.
Maryland.
Oh, I was just making sure
You
you weren't
mean
talking
that-
about Sean
that
G's,
over
because
a-
he said 400 meters for his.
Right.
But in any
Are you
case,
talking about that
speaking. Hold up, what's up?
within-
So speaking of the
okay.
atmospheric effects, like you guys are talking about, this is what I have an issue with in terms of Sean G's thing, and it's unfortunate because he's gone now. But just because you have a change in like vertical, in the vertical, basically like the horizon, there's a drop from vertical. You can't automatically assume that it's due to curvature. It's like a flawed premise that he's working with. And the first video that I found of a time lapse of the horizon, it shows that line where the horizon is moving with atmospheric effects. So it's incorrect to just assume that because there's vertical drop, it's curvature.
What's up? You had another question about it?
Yeah. I just wanted to, because you mentioned that you are a little bit, it's late for you, so you might be a little bit, tired.
No, it's
But
good. Go
if
ahead.
I get it right, then over that 400 feet, they are taking measurements like every about 8. What was it? 8 inches.
They take them at multiple spots. There's 32 spots. I don't know how far apart they are. That the measurements are.
I guess 400 divided by 32, but yeah.
Yeah. I mean, that would be. I think there's a couple. They kind of group up at the ends, but I'm not. It's but each measurement is only 8 inches from the crane to the water.
And at each measurement, they are getting a deviation from a perfect horizontal plane, less than an inch.
Correct.
I get it. Okay.
And it increases
Or less,
as you
less
go
than a millimeter.
distally. Less than a millimeter. That if it was more than that, they'd have to fix the crane, and the fact that they're still using the crane today for testing means the crane wasn't broken, so it was within that millimeter tolerance.
So you're basically claiming that that standing water curves. I just did the quick calculations. 8 inches per mile squared. It would be about a half an inch, like 0.6 of an inch, roughly.
Yeah.
So it depends on the height of whatever they're. So first of all, how are they claiming to measure this? And you're claiming that they're measuring that standing water is actually curving at a half an inch over 400 feet.
Yep. It comes from the fact that we know the rails that it's riding on are curved because we manufactured the rails to be curved. And we
it's
know
the place that you mentioned before, hey? The place that you said you were going to go to, if you could.
So this
Like
is
Indiana
not measured. This is not measured,
No.
but you're just claiming it because they quote unquote manufactured curved rails. That's how they're claiming to measure it.
No. They do measure. They measure the result. Like, okay, so now the rails have been sitting there for longer than I've been alive, right? And they measure from the crane to the water and verify that nothing has changed, and those distances are consistent, and the rail doesn't move up or down in comparison to the water. They're both
It's a double
level.
referencing. That's great. That's actually great. Like for real, what you just said it makes sense. I get it. So the water is referencing. I mean, the rails are referencing the water.
Exactly.
Yeah, they're
They are
both made
measuring
to be
the
level.
rails.
And
It's referencing back 2 times. You get that, right?
Yep. And
The 2 times error only on the human part when they are doing that.
Cool. Didn't you say like a couple months ago that they manufactured the rail to be straight?
yes, straight as in left and right deviation. They also manufactured the rail to be level, and by that they mean in accordance with the curvature of the Earth.
No way did they manufacture it level. They didn't build that into the manufacturing, did they?
Yes, they did. They came up with brand new tolerances.
They pre-leveled it.
The U.S. Corps of Engineers actually had to come up with brand new manufacturing techniques to meet the new tolerance standards set forth by the Navy and this particular.
Hold up. This is the one that you told us about 2 months ago or something when Jeremy was here, and you mentioned it's like in Arkansas or something like that, right? And the rail's underwater.
It's in Maryland.
Maryland.
And the rail is sunken underground.
And you used to you have been in the complex. It's like in some Navy or some sort of, right?
Yep, exactly.
Yeah, and I distinctly remember you saying that the rail was manufactured to be straight, and then we were saying, like, that's what we want. When was it determined to be straight and stuff like that, and when was it manufactured to be straight? And we were asking you about like upkeep and stuff like that.
Yeah, so straight and level. And the straight refers to the left and right deviation, and the level refers to maintaining the equal distance from the unrestrained surface of the water. The only way they are able to do that is to manufacture the rail with a curve.
So it was built straight widthwise, but level lengthwise.
Exactly.
Do you have any substantiation for this?
Yes, I have the blueprints, and I have.
No, do you have a video?
No, videos weren't really a thing back then. At least not in the way they are now.
Well, they're a thing now, right? And the thing still exists, right?
Yeah.
And it's.
Oh yeah. Do you want to see pictures of them using it? Sure.
I mean, I'd love to actually have a level with it.
You say you've been there.
Yes.
Right. You know the procedure, right? They're obviously measuring the water, right? Now, what do you think that's for? I mean, why do they have a thing measuring the distance from the water? Because it's only the distance of this measuring device above the water that it's measuring, right?
Right. That's the important part. That's where the water meets.
So
turf meets the ground.
What are they measuring within the water? What's it there for? I mean, that measuring device surely isn't to measure the water, is it?
No, it's to measure the height of the gantry crane and make sure that the model ships that are placed on said gantry crane, whether they are surface or subsurface ships, maintain a perfect height in the water or under the water. They don't accidentally pull them out and skew their test results or slam them in the bottom and ruin their ships.
Right. So this thing, do they put a flow to the water to test the ships? Because that's what they're doing, right? They're testing the hulls of the ships and how they react in all sorts of different things to try and make it faster, more sleeker, quieter, all of that sort of stuff, right? That's what they're testing, isn't it?
So specifically with the David W. Taylor, it is one of the old styles, which means the ships are actually pulled along by the gantry crane rather than the water being fed along underneath them.
Okay, so when it's being pulled along, what it's actually doing is measuring the amount of travel of the boat, whether the boat lifts or whether it dips and drops into the water, because the water's static. And it's the crane that moves that pulls the boats, right? That's their method of testing.
And they measure the crane to make sure that it doesn't change in distance from the water.
Yeah.
I feel like I've...
Okay, so
by the way,
the boat,
both the same Kool-Aid.
It's the boats that are being tested.
Whoever was asking about why I was there, I just posted a little write-up. No, that's not me in the picture, but it's a little YouTube thing about the races that are held every year.
The resemblance is uncanny.
I know, right?
No, but for real. So you have the water; it's curved. You have this the rail, which you say has been manufactured to be curved, right? They're both level with each other. They're both level. Right. How do you know that instead of them being curved, the water's flat and the rail's flat?
Yeah, so
they reference each other.
You can actually look at how the rail was made, and the manufacturing process is incapable of making a rail that does not have a bend in it.
Really?
Yes.
How did they make LIGO then?
So they used a different manufacturing process. And that's why I was talking about the specific manufacturing process that was invented.
Did one of them pre-level it and the other one pre-horizontal it?
Wow, I was almost in the middle of a sentence there, Bev.
No, go ahead. Tell us about how they could, they didn't have the technology to make it straight, even though they did for the width.
They had the technology. They specifically didn't because they needed their crane not to lift their boats out of the water. That's why they built this thing. They built this thing. Basically, every Navy ship you have ever seen got its start in this pool. That's where it all started.
Yeah, so in terms of the width, you said, for some reason, you mentioned that it was straight. Why would they make it straight? I'm sure it's not that wide. What difference does it make whether it's straight or curved if it's such a small kind of distance?
Because if it was curved, it would cause the rail of the gantry crane to ride up on the rims and raise and lower the boat. It's all about making sure you have the peak performance.
How wide is it?
Maybe 20 feet, 30 feet. It's not that wide. Sorry, I'm trying to remember back.
The steel rail is 30 feet wide?
No, the whole basin. There's a rail on each side.
No, just the rail you said is manufactured to be straight width-wise. How wide
is it?
It's about
2 inches.
2 inches. And
it's a train track.
Saying that it's manufactured to be straight.
You know what a train track looks like?
Yeah.
That's what it is.
Why would you say it's straight? Just because the blueprint says that?
And because of the manufacturing techniques and tolerances that were invented specifically for this rail.
Show me the tolerances where the margin of error is lower than the difference of curvature at 2 inches.
Sure. I'd
love to see that.
That would be the U.S. Army Corps of Engineers building blueprint. Again, I've linked it in this chat. Let me see if I can find it. I don't want to give you the wrong number.
You know how much curvature you have in 2 inches?
Not much.
That's an understatement.
Yeah, dude. How accurate do you think things are and we get?
I don't think train tracks are that accurate.
Train
Let's
tracks are
crack the
not.
numbers. 8 inches per mile squared. How much would
These
2
are not.
inches be?
These are not your average train tracks, are they? Like I said, they had to come up with brand new manufacturing techniques just for that.
These are special ones.
Right.
Hold on, I'm calculating how much
They had
curvature
to
2 inches
pre-level
has.
it. I mean, I don't think they destroy the technology after they did it, because I've never heard of that before. Oh, actually, wait a minute. Lael said he bought some pre-leveled wood for a shelf that he was getting. At the
Being a
builders'
train
merchants.
and having a 8 inches per mile square vertical drop, I mean, you just need a little push. The rest, it goes in perpetual motion.
Yeah, but train tracks, when we talk about them, especially going for long distances, there's gaps between the rails, right? Where one butts up to the next. They don't fit snug. There's play there.
Like a
And
normal
then-
train track. Yeah, we understand.
Right.
That.
There's not in this one.
So it's built in sections, like you say.
No, it's one rail. Because they can't have that tolerance, they can't have that play. Because that would throw off the results of the boats, and that would cost sailors' lives.
You just double spoke that.
How did I double speak?
You just said there are some parts that they meet. They are connected to another.
No, in a normal train track, that's the way it works. In the Bethesda, Maryland underground track, it is one rail because they couldn't fuse them well enough in order to not skew the results and screw up their little boat test and kill sailors.
What?
That's what
How long is this rail?
I feel like we're going in circles. It's a little bit over 400 feet long.
feet long.
Yes.
And there is a deviation of what?
It was my memory says 0.4, but somebody ran the math and said it was 0.6 of an inch.
Wow.
That's slope number, right? That's the slope number.
I don't know what you want to call it. You have lots of terminology that I don't understand, Beth.
We have drop and hump, right? There's two different measurements.
Okay, here we go.
Well, I'm not just saying that. Like Sean is going for the slope, the total distance, the same as Rumpus. This is a very new thing, right? Nobody's ever gone for the total distance slope before. It's never even been thought of.
Yep, you're right, Bev. You were the first one ever to think of it.
No, I'm not thinking of it, right? I'm just saying none of any of the globe proponents have ever thought to measure the drop, the slope number of the, because they've always gone for the hump number, right? Which is the raise in the middle. But this is genius because you bring the quadratic equation into play. There's loads bigger numbers if you're looking for the drop number rather than the hump.
Bev, I don't even think there's
You cannot have a hump.
No raise in the middle.
The hump's much higher. Well, the smaller number, right, to measure over, because you're talking about 120, 130 meters or something like that. Now we've got some of the numbers.
But
we've been given them with Ruhif numbers.
You guys are talking to someone that said at 2 inches, it's precise enough at 2 inches for them to tell that it's straight and not curved.
Yeah.
No, you asked the width of the rail.
Yeah, the width of the rail. You said it's 2 inches,
Yeah.
and they're precise enough to say that over these 2 inches, they know it's straight and not level, not curved. You're insane.
You're conflating two things.
No, I'm not. It's either curved level, according to your conception, or straight. You said the width is straight. This 2 inches are straight. I'm saying, how do you know that?
Right.
You
So
said
it's
it's accurate enough. It's not like your regular railway tracks. It's, you know, super accurate that they could tell beyond the margin of error that it's straight and not level. You're absolutely insane if you believe that.
So once again, the straight is about left and right deviation, and there is none. It runs straight. It doesn't go left or right.
You don't know that over 2 inches. According to your model, over 2 inches, there's like, I can't even do the math.
Wait a minute,
'cause
though. He's
you
just
can't
got
even-
away
So
with
it's-
saying
it's
straight is just
hold
left
on.
and right. That's not
Hold
what
on.
straight means.
Hold on. It's 400 feet long. It's 2
Yeah,
inches
correct.
wide, dude.
I know, and you're saying over these 2
My
inches, you
walls
know
are
it's
straight,
straight.
and they are not level.
You're not saying it could be
No.
level, you know.
No.
it's probably
Not
level.
over the.
You're
Stop.
saying you know
Hold
it's
on.
straight
Hold on.
over these 2 inches.
Pause. Not over the 2 inches. That's the width of the
Bro,
beam.
you said the 2 inches are straight. They're manufactured to be straight, not level. You said that.
No. The entire rail.
You said the
You're
entire rail is manufactured to be curved, level.
Right.
You're contradicting yourself now. You said the width part is straight, not level.
The width part is just the width. It stays the same width the whole way.
I know,
don't know
but you're saying that those 2 inches are straight and not level. As if you could tell the difference at 2 inches, when you really can't. Like, can you tell me how much
I don't-
curvature you have in 2 inches?
I don't know what.
My point
It's-
is, the
it's
fact
flat,
that you
dude.
even
What
say
do you-
that means
It's
you've got your
true.
head up your ass.
I have no idea what you're even trying to say right now.
Bro,
It's
you
2
said the
inches
2
wide.
inches, the width was straight and not level.
I never said that.
He did say that. You did say
You
that.
did say that.
Right? But, I mean, we're getting skewed up in it, right? Percentage is right. You, by saying one is straight and the other isn't, you are differentiating between straight and not straight. Right? That's
Okay.
what I think that's what percentage is getting at. You personally can differentiate between straight and not straight. Now you're
Well,
saying
that's part of it, but the other part is that he's completely ignorant on the subject if he's saying that you can tell the difference between a straight and not straight surface over 2 inches according to like Earth's curve.
You're not looking across 2 inches. You're looking down 400 feet.
You are
look
for the width of it, which you said was manufactured to be straight.
yeah, but
And I
that's
said,
not,
how do you know that it's
No.
straight and not level, width-wise? And you said that's the way they manufacture it, like
Not everything
railway
has
tracks
to be
that are super
level.
accurate.
you can have
It's not
something
level.
that's straight and not level, right? You don't
It-
have to manufacture something to be level.
It's
How do you know it's not leveled, Kool-Aid? The width-wise.
It's not leveled with. What does that even mean? I'm
How
sorry.
do you know these 2 inches width-wise are not level?
Yeah, is there one of these
I-
rails on either side of the tank?
Yes.
Right, well, there you go. How do you know that they are straight when you're referencing one rail to the other and not level? I think that's what percentage is saying, right? Percentage? Now,
How would
it
I
makes it
reference
different
the-
now. We've
how
got
would I
two,
reference-
2 inches, one on either side of the water.
No, it doesn't matter which one. I think you might be misunderstanding me a little bit, Bev.
I'm
But
just trying to
basically,
reference the
for
level
some reason,
part
he
of it.
drew, like, he made the positive claim. I don't know why he even thought it was necessary to say that width-wise, it's straight. It's not level.
No. I wasn't saying widthwise. The
You
width
did.
is.
You
con-
said lengthwise,
Okay, hold
it's
on, hold
level, not straight.
Tied up in the
Okay,
weeds.
stop. If I misspoke, I apologize. I probably did. That's on me.
I don't
What
think
I
you
meant-
did. I think you
what
just
I meant-
realized now. Go ahead.
What I meant to say, and what I've been trying to say this whole time. Okay, if we put this stupid rail in on a graph, right?
It'll
The-
curve lengthwise.
There's two
It will
rails
curve-
now, though.
Okay, hold on. I'll bring the
Just a
second
coin,
rail in
doesn't matter.
just a sec.
No,
The
it does.
rail
It
on the
does
right.
matter.
Okay, hold on. The rail on the right. Okay. So that rail, if we plotted it, it would go. It would not. The X and Y numbers would not change. Only the Z number would change. Right.
Okay. Yes, it'll curve.
If we plotted the left rail, the X and Y or the Z number will change the exact same amount as the right rail, And the X and Y numbers will not change, just like they didn't change on the other ones.
Yes, that's understandable. You said that it's lengthwise.
That's what I meant.
Length is level. The length is curving throughout the length of it, right?
Yes.
But you also said, again, that the width of each one of these rails is 2 inches. You said the width of it is manufactured to be straight, not level. And I'm asking you, why would you even make that distinction when it's impossible for you to prove it?
If I said that, it was a misspeak. And because that doesn't make any sense, because that doesn't matter.
Well, I mean, you said it, and I asked you about it, and then you supported it by saying, special manufacturing techniques, and they're like railways that are really accurate.
I was talking about the overall length and not the width. I apologize if I didn't make that clear. I was never talking about the width.
All right, so as far as you know, width-wise, it's probably level as well, right?
Do you mean, right, when we're going on this crane, can this crane go across the diagonals of this pool? Could it start at one side and work its way all the way to the other side across the length of it? As in, can you put an X and a Y value to the pool?
Yes.
Oh, right. Now, at each side, let's say we'll call the X the width. So that picture that I'm looking at there that WhatsApp's just put in, is that the pool?
Sure. Yes.
Right. Okay. Now
that's the human-powered
width of it,
competition.
Right.
Okay.
Let's call the width of it X. Now, is there a rail on either side of that pool for the crane to go along?
It's probably more in the center, but yeah.
So,
where's the rail in that picture? Can you point to the rail?
Basically, he's asking, where's the rail relative to the basin of water?
Right. Do you see the girl in the wetsuit?
Yeah.
Behind her, you see the rail? It's underneath the AP logo. You can literally see it right there.
No, in the picture.
Take her back and take her back and go to the right. We're going to reach the edge of the screen. Go up. You'll see the rail.
In the air.
Other rail, yes.
Okay.
The other rail.
Yeah.
You can. Okay, you see the part that's a little bit wider on the far left-hand side, and there's a thing that kind of looks like maybe a T sticking down. That's sitting on top of the rail.
Can you do a screenshot and just put a couple of arrows there? That would be a little bit better.
Can I just do this?
The point is, this doesn't help at all because both of them are the same. Like, allegedly, the rail and the water are both curved.
Here's
what we need
rail.
is something to hold against it to show that they're not the same.
And here's a rail.
Okay. Right, so those two rails, we'll call them the two X rails. Oh.
Okay.
And
yeah,
they go all the length of it. Now, from one to the other of those, are they level? Can I hear myself?
From here to here, it is level. Yes.
Bev, everything is level in this thing. Everything is level. The only difference is he claims that the level is curved. It could easily work with everything being level and flat. He has no substantiation as to if it's actually curved. It's just blueprint.
Yeah, I'm just trying to get the layout of exactly what we're saying here, right? So we've got those two rails, and they go all the way down. Now, across them, I'm guessing, from one side to the other, that has to be level across the water.
Yes.
Along the width way, right?
And
so
that's where
there is a level dimension in that axis, and then across the length of the pool, there is also another level. You've got two directions of level that are opposed to each other. You've got an X and a Y axis of that pool.
All right.
Now, the crane is going to do the Z axis, right?
So. Yes. Okay. I'm with you. Yep. Mm-hmm. And where you attach the model. Yep.
So the measurements that would be made that you say are being made are being made by the crane with reference to the water. Right? So the crane has two rails that run along one axis. They have had to have been leveled across the other axis, one X, one Y, and the crane actually measures the Z axis, right?
Yes.
Okay. Now, you're saying that it measures an amount.
Mhm.
Where is that amount
small
measured?
amount. So the amount. Okay, the measurement is from the crane to the surface of the water.
Yes.
It is level at all times. It's the same measurement at every point.
So it's 0 then.
It's
No, it's going to be like a foot underwater or something.
well, no, it's above water. It's
Or-
about 8 inches,
A foot.
a
Oh,
little
so
bit under 8 inches.
The crane comes all the way down. It gets hung.
Yes, and that is the mounting point for the model ships that they then drag from one end of this pool to the other to see how these ships perform at speed. That's what
begging the
this whole
question,
thing
Bev.
does.
He's begging the question because he's saying if it wasn't created to be curved, the rail, then it would it would hit the water or come out of the water or what have you.
Yeah, that's what
So-
he's saying. The rails.
So he's
the
assuming that
crane's
it
on.
was manufactured to be curved, when in reality it could just be that everything is horizontal.
Well, like I say, if you've got two rails either side and they've been leveled, then there is a straight line that can be drawn between those two, right? But on the other axis, the length axis, that is actually the rail, right? So you're saying that the straight line that would be drawn would either cut through it or would be tangent to the line in one direction, right? The length, the long direction. Whereas
There
in
would
the
be
other direction,
deviation.
because you've only got two rails, you can only level it as though it's horizontal.
There will be deviation from horizontal from any point on this rail.
All the way across. Like, this is what I'm saying. From one rail to the other, you would
Measuring
level it
along
and
the
make
same
sure they were
rail.
both on the same level. Now,
Right.
that would have to be horizontal.
Yes.
There's no other way that could be. So that
And that
level
is.
horizontal.
Right.
So
Wait, say that last part again, Bev?
the two across, horizontal, right?
Right.
Now, the length of it is not horizontal, you're saying?
Correct.
Why are you saying the two across have to be horizontal, Kool-Aid?
Because the gantry crane sits flat. It's not tilted to one side. And if you ever walk on with one foot on a side or a step,
How far away are the rails from each other?
about
How do
30
you
feet.
establish that? Is it the question I would like to know? How do you establish that the crane is leveled or straight or horizontal, whatever you want to call?
3 feet from each other?
No, 30 or 40.
So each, like the right train track and the left train track, are 30 or 40 feet from each other?
Yeah, roughly.
That's pretty big.
So what's
Okay.
the margin of error on this level?
Less than a millimeter.
So what's the
is what they
curvature
allow.
on 30 feet?
How do you establish that? How do you establish that it's off level a millimeter? With
That's
what
what-
instrument? Which instrument you're gonna use to determine if it's off level? Please.
It is level across the
highly-
width, right?
Highly calibrated laser rangefinders, George.
Laser rangefinders.
So it's not as ridiculous a claim
What?
as last time when he said that the 2
Why-
inches
why
were
do you want to
actually
know
straight,
how far
but now he's
something
saying
away is,
30
right?
inches. I mean, 30 feet
You-
are straight.
Percentage,
You need
please.
to know how.
You've
you
been
need to
saying
know
up
how
until
far-
now that they're using the water as a reference for the height of this crane, but not lasers. You never mentioned lasers up until now.
Yes, I have. It's
Water is the
always
gauging
been-
tool as to where they measure the distance from the crane to the
it's
water.
been laser
And
rangefinders.
like you
from the
said, it
gantry
goes
crane.
on the zero line all the way through. There is no deviation. That's what level is.
Correspondingly.
Yes. It is laser rangefinders from the gantry crane to the surface of understrain water along a fixed path that we know is a curve, that we manufacture to be a curve, that we can measure to be a curve.
Except those last three are false. You actually don't know if it's all curved or if it's all flat. You're just
It's
told
begging the question
that it's curved.
Except for the measurements and the manufacturing.
No, the measurements.
technique.
Listen, okay,
Except for the assumption,
hold on,
yeah.
George. Let me just kind of nail this into his head. You can't rely on this for anything because they're both the exact same. You have no reference point because not one is different than the other in terms of the water and in terms of the gantry crane and in terms of the railing. They're all the same thing. They're all curved according to you, right?
Right, but you can
So you
shoot
don't have-
horizontal.
Hold up. So you'd have to introduce another variable, another thing, reference thing, to either say that they're all level or all curved, right? You'd have to introduce something that's not like them. So if you're saying that they're all curved, you have to introduce something that's straight. Like for instance, if you took some like neutrally buoyant line from one end to the other end of like this long arc rail, basically, and showed that, you know, at the middle point there's a disparity. Or if you took something that was manufactured to be curved and introduced it to like if they were all straight, you know, to show that there's a disparity. Right. That's what you need to do.
We can shoot.
I understand, but you didn't mention any of this stuff. You just, and this is what
horizontal tangents.
One second, bro. My point is, what's up said this from the beginning. He said you have two things that are referencing each other that are exactly the same. That doesn't prove anything. You need something different. You need a control, and you haven't introduced that. So I would urge you next time you bring this up as an argument to mention how they brought in something else, like something manufactured to be straight or what have you, and compared it as the control. Otherwise, it's absolutely useless, and I wouldn't bring it up again.
Okay. Fair enough. Still better than the Black Swan.
Not at all. But ideally, like, you know, we would have a neutrally buoyant line that we could kind of tie it between each end of the rail or something like that.
Well, hold on. If you tied a neutrally buoyant line, all that's going to happen is it's going to find its buoyancy location either being slightly subsurface or surface level, and it's going to follow the curvature of the water. What is that going to prove?
No, because if it's neutrally buoyant throughout the entirety of the line, it's not going to find any sort of, you know, equilibrium or what have you. You kind of manufacture the line to be the same density as all of the water, right? And in that case, wherever you put it, like especially if this is kind of like a very still body of water, you can. I mean, you can affect the density. Yes, you can. You can, you know, if it's already
pressure increases by 1 atmosphere every 33 feet, you go down. That is an undeniable fact.
Okay.
You cannot manufacture something to be the same, have the same density and pressure at 1 atmosphere as it does at 50 atmospheres.
I understand, but that's not the point. The point is when you tighten it from one end to the other, right, and get rid of as much slack as possible, you're basically making the shortest distance between those two ends, right? And those two ends you're saying are curving. So if you get the shortest distance, then you're basically like, you know, you're drawing a line through an arc. And in that case, you would have a disparity at the middle. You understand? So the only reason we have neutrally buoyant line is so that there isn't, like, you know, too much slack or too much buoyancy. It's just making it easier to get it as tight as possible.
Okay. I mean, if you just want to type on lots of things that you could do and disregard the fact that they are known measurements, cool.
They're not measurements if they have nothing to compare against. If they're comparing against each other, it doesn't help us. Because you could say they're all flat or they're all curved. It doesn't make a difference. You have to introduce, again, a controlled variable. Like a variable that's different from them to reference to.
There is. He's got two rails that are making a square rectangular function. You use the diagonals. I mean, like, you just use geometry.
Yeah, but how are you going to actually measure that, Bev?
He's got a crane that is a measuring device. that is
Actually,
not affixed in the center at all. There is diagonals that can be measured. Now, he's measuring the slope, right, of water.
And you can do this yourself.
Yeah,
this
you
place
can.
is open
You can
for...
measure the slope of the water both ways if you've got a device that can measure the slope of the water. Right, there is a deviance between the square track that you've got and the water that you say you can measure to ultra high accuracies.
I don't think the
It's a
device
simple
allows
case
for that.
of geometry. This.
Yeah,
Really
I don't think the device
simple.
allows for that. I think the gantry crane takes things along the rail together simultaneously.
That's it. Yep.
But if the gantry crane is hanging perpendicular, right, from wherever it's hanging from,
It's rolling on the rails, Bev.
Yeah, but in between, right?
It's
It's
solid.
rolling on the rails. Where is the crane?
That is the crane.
Right. So the crane rolls on
Okay,
the
hold on.
rails
Wait,
and
pause.
hangs something down to the water, right?
No.
Right. Okay.
You're thinking of crane like building crane, and that's not what it
I'm
is.
just thinking of a crane, a device that runs on two rails that drops
So-
something
No, the
down to
boat is
measure
probably
the
on the
water
rails.
that's in between those two
It's-
rails. It moves along the
Okay.
rails and it measures the distance between the crane, like the level of the crane, the tracks it's on, and the surface of the water underneath it, right?
It doesn't do any of that measuring. It just pulls the things along.
Yep.
It doesn't
And
measure anything,
don't think
does
of,
it not?
Don't think of it as a crane.
Does
and-
it measure anything?
No, the only measurement that he's
Percentage,
talking
I'm
about.
not asking you.
Okay, well,
Kool-Aid, does this crane measure anything?
Only when strapped with the calibration equipment. Most of the time, no.
Bev, the measurement is just from
What
the
calibration
rail
equipment?
above the water. He's saying that they measured the altitude of the rail above the water all the way through, and that it remained the same.
And the crane doesn't. It doesn't have any mechanical parts. It's just a.
How do
Solid.
they measure it then? That's what I'm after. That's
It's a
what we're
solid
after. The
piece, that bit.
measurement numbers. You said you give us the numbers. Now, where are those
Okay,
numbers coming from? What
I'll
is the
look
thing that
again.
was measured, please?
This is going to be the last time I'm going to answer this for you, Bev. It is the measurement of the gantry crane to the surface of the water using short-range laser rangefinders at a distance of less than 8 inches.
The measurement was less than 8 inches.
Right.
The measurement distance was less than 8 inches.
Okay, say it 9 different ways.
Or the
Yes.
deviance was less than 8 inches. Or the drop, or the slope was
Your
less
wording
than 8
on that
inches.
last part was kind of ambiguous, Kool-Aid. Are you saying that the measurement itself, like, the difference between the surface of the water and the crane or the railing or whatever, is 8 inches all the way through? Or are you saying that the laser itself was 8 inches away when it measured it?
Both. It was sitting on the crane and measuring to the surface of the water, and it
I
came
see.
up with 8 inches.
8 inches
Or less than
all
eight.
All the way
over.
through. Yeah.
All
All the
over.
way through. Yeah.
Even
yeah.
in the
We
center.
understand. Flat.
Yes. At every single point.
Okay.
Yeah, we understand. Flat. That's what
Yeah,
it
yeah,
means.
definitely.
Anyway, if you have proof of a globe, P, then you would present it to us, Q. You don't present any proof of a globe, Q. Therefore, not P. You
Okay,
guys have
you don't-
nothing.
You don't like this one?
This is why I said you need to take the ends, and you could, Bev, like you said, in terms of taking the diagonal between one rail and the other one. That's fine too. I would just stick with one rail because then you're not introducing as many variables, right?
No, the
But you just
crane
take-
runs onto the rails, though. You have to take that factor in, right? You cannot
Okay.
dismiss the other rail. You have to take both rails as one axis, and the length of the pool, as the other axis. You have to have that.
Bev, why
That's the
don't-
only
No,
way
you
can
don't
do it.
necessarily. If you're
X
just
and
using,
Y.
if you're just using line to tie it to the ends of the rail, you could just use one rail, or you could use the other rail as well, but beginning and end of the rail. and it should show a disparity between, if it's actually curved, if it's actually manufactured to be curved, there should be a disparity between this straight line that you're making with this, this kind of high-powered tensile line or whatever, and the rail itself. There will be a disparity regardless if you use one rail or if you hop to like the other rail to get the end. You're still going to have a straight line between the beginning and end.
And even whatever structure is supporting this, or whatever it is supported on, how are you going to establish if it's actually straight or whatever level you want to call, guys, based in what parameters? How would you do it? You're going to build it first and then guess if it's or not level. Then you're going to come with the crane and see if the crane is dropping or not. That's nonsensical. Every job has a preparation to be done, and these things, if they need to be leveled as they are, the precision it's precise. That's what I'm saying. The preparation for this, they just needed to come with the rail and lay it on the top.
Yep. And the rail had
and they use the water.
They
use the water as a gauging tool, to establish a level all throughout.
Actually, the water was already in place when the rail was laid.
Yeah, but water doesn't curve, does it?
Yes, it does.
No,
as demonstrated by the fact that the curved
no, it's
rail
not demonstrated by that
is
fact,
level.
No.
Okay.
The curved rail is level. Wow. You don't know what level is, man.
You honestly don't know what level is.
Okay.
How would you calibrate?
Like
tell me one thing. How you calibrate this crane to be, like you described it, straight in order to be at the same altitude throughout on the top of the water? How would you calibrate this crane? With which instrument?
How do they calibrate it? It hasn't come out of calibration because it was manufactured in such a way as to shield it.
Now, how you know the crane, the object is going to go on the rail. How do you establish that the crane is straight?
They use complicated drafting equipment. The nerds pour over it about every 3 years. This is at a college. They rip it apart all the time.
Kool-Aid. So you said the rail was manufactured to be curved. It's in the blueprints.
Yep.
Do you have the blueprints? And can you also provide with them the blueprints of the floor of the basin itself?
Speak again.
You know what?
So now it was built curved now.
Hold up, George. Yeah, he said it's manufactured to be curved.
I can give you the direct number where if you can call them.
No,
and
I'd rather just use
every question.
Provide the blueprints, since you said you looked at the blueprints and they're manufactured to be curved.
Sure.
That'd be great.
Okay.
And while you're at it, please let me finish, George. Please provide the blueprints for the building itself that houses this basin to show that the floor of it is also manufactured to be curved.
It's actually not. And you can see the difference.
Okay, so it's all right. So now the floor is flat.
Yep.
It's straight. They manufactured the floor to be straight.
Yep. And it's also broken into 4 different rooms above the basin. It's really cool. It's,
Come on, guys. Straight means nothing.
Division of
okay, so you're saying that the hold up, the floor itself, they manufactured it to be flat. How?
Here's the information. Anything you could want is right there.
I'd like to see both blueprints for the floor of this basin and for the rail, and I want to see one is manufactured with a curve and one is manufactured to be flat.
They have all the blueprints and stock photos of all of their basins, including the one that we've been discussing here.
Can you please provide just the 2 that I asked for? Because I don't know what I'm looking for, and I don't want to go on a wild goose chase.
You've never had this conversation before, have you not?
David Taylor Memorial Model Basin?
No, I have not.
You two.
Yeah,
we talked briefly about it, but he didn't say that.
But you're not asking the right question.
I'm not bothered about all of these technical details. I'm on about the simplicity, so people can understand what's going on.
Yeah, but Bev, this is
somebody seems to be claiming as though this is a proof, right?
Hold up, Bev. He's saying that
I think George is with me on this. We're trying to just find what's going on. You seem to be confusing everything, percentage.
No, relax, Bev. Just listen. So he's saying that the floor now is manufactured to be straight like LIGO. If that's the case, then
No, not straight like LIGO. It's not nearly that close. Is
it straight or not straight?
The
It's
floor
manufactured
just looks
to-
like the floor, right? You mean the concrete bits?
Right.
Yeah, he's saying it's not level.
The floor above it is manufactured to normal
It's
U.S.
manufactured.
military standard.
But you said
Not
you
the
built
floor
into
above,
the
the
bedrock.
bottom of the basin of water.
Oh,
Like the
smooth.
base of it. You said it's manufactured to be straight, not
No,
curved.
no. I was talking about the floor above it being built by engineers. The floor of the basin itself is smooth. I don't know what kind of curvature it has on it. It doesn't really matter.
It does matter, because if they had manufactured it to be straight, we could just measure from the base to the surface
Wasn't
of water,
it in the bedrock?
and there should be a disparity.
Yes, it is carved into the bedrock.
Right, now, did they manufacture the bedrock?
No.
Right, okay, so it wasn't manufactured then, right?
Built to be straight.
They carved into the bedrock.
Okay, now, we're talking about the floor, right?
floor
Are we
of what?
talking about a manufactured floor?
Hold on, pause. Which floor are we talking about?
No, we were
That's
talking
exactly.
about the
I don't
bedrock,
know.
Bev.
You're answering the question about something
Okay.
that was manufactured. You
So,
claimed that the floor was
manufactured floor
manufactured to be something.
is
Percentage
the
wants
next-
to know whether it's straight or flat or whatever.
Okay, stop.
It's just
Hold
the
on,
floor that
Bev.
people are walking on, right?
Bev.
No, not the floor that people are walking on. I was asking about the bedrock itself, the floor
And-
of the basin of water.
We had a miscommunication. I was talking about the floor people were walking on above him. He was talking about
Now
the
we've got
basin
it
of the water.
clarified, right? The
Now it's
floor,
clarified.
the
And you don't know
bedrock,
whether
the
it's
water.
flat
I
or
don't
curved.
know.
Does the
know they
water
said the
care?
water
The
was
water
already
level
there.
care about what's underneath it? I'd say no percentage.
It
It's
does
a
matter, Bev,
ridiculous
because
question. It doesn't matter.
No, it's
at
not
all.
ridiculous. You're not understanding. Because if he
Yeah, it
says
doesn't
that
matter.
the base of that basin, the
It
bedrock,
sounds like you're
was carved to
obfuscating
be
this.
flat, then you can just measure from the surface of water to the bedrock between the beginning, middle, and end and see a difference.
No, he said the water was already there when they built this thing.
I know.
What? No. It was there when they laid the rail. They carved out the depression and the basin for the bedrock.
And whatever
so
that
it was
is
put
doesn't
together in
care
level,
about the
covers the
water.
level.
Zero.
I'm sorry. 3 people talked. What?
Okay, the surface of the water cares nothing about the shape of the bedrock underneath it. As soon as they put
Incorrect,
water
Bev.
in,
You're
we
incorrect.
don't care about the bed rock. We just care about the surface of the water. Oh, we do, right?
That's
In
correct.
order for measuring and telling the difference for level and straight and whatever, we are going to use the water as the reference. That's all we are cared about. Me and George, anyway. We don't want
Obviously,
any
but
other
You're
obfuscation.
wrong to jump to that conclusion,
Yeah.
because if he said that they carved the bedrock to be flat, not curved, then you can take the water level, the surface of water, and measure down, measure to the bedrock, and see if there's a
Yes.
difference.
But what you
To be
do then
clear,
is you use
I
the
never
water
said that.
as your
Nothing else.
reference
Hold
again.
on. Hold on, guys. To be clear, I never said that. I was talking about the floor above it and talking about much less degree of precision. I was never at any time referencing the
Yeah.
precision.
Yeah, we know.
You're
we know
both
you
obfuscating the fact
misunderstood
that
it,
as
but
soon as
being
the
said-
water goes in, the water becomes the reference, right? That's what we're talking about. We're talking about the water.
Obviously, Bev, I don't know why
Okay.
you're not understanding this. If, hypothetically, he doesn't know, and it's probably level, but if, hypothetically, the bedrock was carved to be flat, then you can compare the surface of the water down to the bedrock and see a difference. Because one is level and curved according to
That
them,
means
and the other one
nothing.
would be flat. Jeez.
Straight and flat in this context means nothing. My walls
Lord
are
have mercy.
straight. My walls are straight and flat. They are not level. When you talk
Obviously.
about level and horizontal, they have a specific vector. Yeah, very
Yeah.
specific vector.
Well said, George.
It doesn't curve. A
that's why-
horizontal line, an horizontal line established physically with a level line, with a level. Yeah, in
I
reality.
hope the other listeners understood what I was getting at, because you guys are getting hard to talk to.
Why don't we change the subject? How about the Vendée Globe?
The globe what?
The Vendée Globe, a sailboat race run every 4 years. Last run last year.
And this is going to prove what? The globe?
No, won't prove anything, but it is definitely evidence of the shape of the world that we live on.
So there is a shape attached to it. I wonder which one.
Well, it's an oblate spheroid with radius of 3959 and all of that.
I thought we just established that water conforms to its container, the container that it's in, regardless of the surface of the base. The water conforms to the container that it's in. That's how we do ice cream and everything. You know, ice cubes. You put water in a container, it comes out with the shape of it.
Right. For small
So the surface
areas.
of the water is always level, always horizontal.
It will always take the shape. Water will always react to all the forces on it, just like...
No, it will take the shape of the container that it's in. Like when you pour a glass of water, or a swimming pool, or a basin, or a pond. Doesn't change.
Then explain the Vendée Globe to me, please.
Kool-Aid, real quick. The rails in this like basin, can they be moved? Can their like height be manipulated? Can they be put below the water, for instance?
I mean, hypothetically, you could rip them out and do it, but...
No, I'm saying like in terms of the manufacturing, the setup. Are they adjustable?
No.
Okay.
Yeah, when they do things like submarine testing and they need to be below the water, they actually use a harness that dangles from the gantry crane.
Fair enough.
Yeah, but the Vendée Globe, these sailors went out and actually sailed around the world. They know their distance. They know their speed. We know how long it took them. So that gives us pretty accurate distance for this race.
Do you have a reference point?
A reference point. I have lots of reference points. Which would you like?
Let me say, like, do you have a control variable?
What do you mean by that?
Because if you're like, propping this up as a proof, you need a control variable so that we can compare the two, right?
Sure. Like the known speed possible out of these boats under optimal conditions?
No.
Okay. What would you like?
We just...
You tell me. It's your proof.
These are special boats.
These are special boats. These are the Amoca 60s.
Yeah, they only work on a sphere, isn't it?
But no, I'm not. Trust me, there's not one person here I think I'm going to convince. I've been here way too long to think like.
Well,
that.
I don't even. Yeah, it sounds like you don't even have that measurement, the one that you were claiming, and
I said it was a hypothetical test, didn't I? I said that at least 4 times now, so you don't need to make it sound like I said I've done it.
Well, one way to verify it would be to build. To build, this would be pretty expensive, but let's say you had that. Let's just say 10 miles. So you've got a 2,000 foot tall point at 10 miles away from another 2,000 foot elevation point, and you're at the top of that. One way that would be pretty cool to do, but expensive, but perhaps would verify it, would be to build like towers every whatever it would be, every, let's just say 1/10 of a mile, you would build a tower. So you'd have like 10 of them. So if you're going 10 miles, you'd have 100 of these towers. And they would all be measured to be the exact height, the exact altitude from sea level. And
elevation.
Same elevation, yeah. And then you would have all those towers. And of course, on a globe Earth, those would start to drop. And on a stationary plane, well, it doesn't have to be stationary, but on a planar surface, you're going to get, just like water levels create, you're going to get that straight line. You're going to get the elevation of each of those towers between you and that location will all be perpendicular. They'll be parallel, and they will create the XYZ axis, and that can be verified that way.
Okay. Would you say 400 meters is too far to use in optics?
It depends, but that's getting up there. It depends on what type of equipment you're talking about and what you're doing.
A water level and we'll say a total station, so that the optics can be used that way. Because you can't. I don't think anyone can refute a total station can be accurate at 400 meters. I won't use auto level anymore.
Okay, so you're going, but you're not. You're trying to say a total station at 400 meters per Earth curve. Is that where? Is that?
You can. It depends on what you're using. Because in the same test that I was talking about, the two mountains, you can do with, say, a water level, like that's been being talked about.
Yeah. Well, the idea I said, like if you had towers that were physical and you could add water levels to those. So you could have water levels, you could, because that's what I think these demonstration setups that are coming in the future that are going to, be the sort of finale to this, a lot of this stuff in the coming years, like to be able to combine multiple things. So you could do plumb bobs, you could do water levels, and you could do towers that are all at the same altitude. They're all squared up. They're all perpendicular. They're all at a particular elevation. You'd have water levels. You'd be able to also do the plumb bob as well and take those measurements, and that would be incredible. And you could literally see it squaring up literally all the way along, that there's no curvature. That would be amazing.
If you enjoyed the content, please support On the Level and future projects. Membership subscriptions available now, or come and get involved at Next Level Discord server. Thank you.